everyone. In this video, we're going to talk about chords. So in this picture that we have here, I labeled line segment PQ is a chord. So what's a chord? A chord is a line segment that connects the end point of an arc. So there's like one point here and the other point here. So it should touch the circle. So both of these end points should touch the circle. We remember that the diameter is the longest of all the chords in a circle. Okay, so let's have the chord theorem here. So let's take this example right here as well. So chord theorem states that a perpendicular bisector, perpendicular means it's forming 90 degrees. Bisector means we've been using bisector in the previous videos. Bisector means it was cut in half or cut into two equal parts. That's what we mean by bisector. Passing through the center of a circle cuts the chord into two equal parts. So if a chord passes through the center, pretty much it passes through, this is point C right here is the center. And so it cuts this chord. So our chord right here is AD. So the measure, one way that we know that it is a perpendicular bisector is that it has this small square in here. It's telling us that it's perpendicular. That means it measures 90 degrees. And so it cuts this AD into two equal parts. AB is equal to BD. And that's what we got over here. If and only if this CB or BC line segment is forming 90-degree angle when it crosses with AD. So it has to be a 90-degree angle right here. That's a time that we can say that it's a perpendicular bisector. At this time, I would encourage you to pause this video and try these two problems out on your own. And when you're done, unpause it and check your answer. Okay, so just by looking at this and using the theorem that we got over here, we can therefore say that this first thing that we need to look at, is it a perpendicular bisector? This line right here is telling us that it's perpendicular bisector because this small square is saying that. And this is a chord. And so if this was 17, this should also be 17. So it was because it was cut into two equal parts. So this chord was cut in half or cut into two equal parts. So that is 17 is the X. Did you get 17 on the first one? Good. Perfect. Now let's move on to the second one right here. So in this case, we have again another perpendicular bisector. This line right here is a perpendicular bisector. We know that because there's a small square indicating that it forms 90-degree angle. So then we can tell that this chord MR was cut in half. So our KR here is 11 because again, bisector means it cuts the line segment into two equal parts. So 11 and 11. So KR is 11. And then MR is, we add both of them since both of them are 11 and 11. So that should be a 22. Did you get the same answer as this? Good. Perfect. Now let's move on to the next example right here. So it's pretty much the same thing, but this time around we have expressions as the length of the chord. So since we know that this is a perpendicular bisector, CB is a perpendicular bisector. We know that because there's a small square. This indicates 90. So that means this was cut in half or this was cut into two equal parts so that we can set up our equation to be AB is equal to BD. So this half is equal to the other half since that's a chord right here. So AB is 20 plus 5x equals, that's BD is 16 plus 3x. So then from here, we can subtract 3x from both sides. So minus 3x here. So then we can cross the 3x out. So we get the 20. 5 minus 3x, 5x minus 3x is 2x. So that's a 2x equals 16. So then we subtract 20 from both sides, minus 20 here. So we can cross the 20 So we're left with 2x equals -4. So then from here, we divide both sides by 2, divide this by 2 here. So then our x value is a -2. So our x here is a -2. Now let's determine AB. To do that, we're supposed to plug the value of x into here. So that would be 20 plus 5 times, again, our x is -2. So then we go ahead and say that's 20 minus 10. So that's 20 minus 10 is 10. So the length of AB is 10. Now we're expecting BD to be 10, but then we have to show the work again to see if it's really 10. Again, we're expecting BD to be 10 since this have been cut in half or cut into 2 equal parts. So if this first piece is 10, the other half should be 10 as well. But we have to show the work on that one. So that is 16 plus 3 times our x is -2. So then we go ahead and write 16, that's a -6, so that's a 10. And so we got a 10 for BD. And so our AD, the whole thing, is 10. So if this side is 10, this side is 10. So the whole thing AD is 20. Okay. Now let's have the third problem right here. So we have this perpendicular bisector again. So this is a perpendicular bisector and we know it because there's a small square indicating that it is 90. So this was cut in half and these two sides are equal. So if this side is 21, I could go ahead and say that this side as well is 21 since both of them have been cut into 2 equal parts. So then from here we can see a right triangle. So I'm going to take the right triangle off of the actual picture. So let's take this triangle off because others are gonna get distracted with all the rest of the line segments that are inside the circle. So I'm taking this triangle off of this circle. So the triangle that we're looking at is, this one is a measure of 21. This is 13. So this side, so these are the sides that are corresponding. So this side corresponds to each other. This side corresponds to each other. And so we have the x on this side right here. So what I did was I took the right triangle out from the circle. So this is our x there. So then from here, to solve for x, we're going to use the Pythagorean theorem. So remember, Pythagorean theorem formula is leg squared plus leg squared equals hypotenuse squared. So the two legs here are 13. So 13 squared plus 21 squared equals the hypotenuse squared is x squared. So then from here, we can go ahead and square this. So 13 squared would be 169 plus 21 squared is 441 equals x squared. So we add these two together. That would be 610 equals x squared. We want the x, so then we are going to square root both sides. So this would come out, x is equal to, we can round it off. So if you use calculator, square root of 610 is 24.70. So the length of x right here is 24.70. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!